It's a pleasure meeting you again in my mathematics class. Let me continue with Laplace transform. Today the problem that I have taken to explain to you how the Laplace transform problem can be done. Taking this example, finding the Laplace transform of t e to the power of 2t sine 3t. That is, to find L of t e to the power of 2t sine 3t. So this is what we have to find. Before I can take you by two methods. This is how it should be understood is, I will write this as L of t e to the power of 2t into sine 3t as, I will write this as imaginary part of L of t e to the power of 2t into e to the power of I 3t, because I 3t e to the power of I 3t is equal to cos 3t plus I sin 3t. Using De Moivre's theorem, I can write this e to the power of I 3t as, so we want the value of this imaginary part is this. So instead of, I will do this as finding the imaginary part of the Laplace transform of this. Now this is equal to, so I can write this as, this is nothing but as per definition, imaginary part of, imaginary part of 0 to infinity, it is t e to the power of 2t e to the power of I 3t into e to the power of minus st into dt. So I can use the definition, by definition. This is by definition of Laplace transform. So this is by definition of Laplace transform. So I can write this as imaginary part of 0 to t into e to the power of minus of s minus 2 minus 3i into t into dt. So I can write this as e to the power of, I take this minus sign outside, so minus s minus 2 minus 3i. You see that minus s plus 2t and plus 3it. So you are getting the same thing. So I write it, put it in this way. Now this, I use Bernoulli's method. I use Bernoulli's method of integration. So this can be written as t into, this is imaginary part of t into, this is t into e to the power of minus s minus 2 minus 3i of t divided by minus of s minus 2 minus 3i 0 to infinity. Let us, I will find I will use Bernoulli's method of integration. Here t into e to the power of minus this, and take the differentiation of t, that is 1, and the integration of this. The integration of this is nothing but, integral of e to the power of minus s minus 2 minus 3i of t divided by minus of s minus 2 minus 3i into dt. So this is what you will get. Now you see that this will become as, so this is 0. imaginary part. So this is imaginary part of, this is 0 minus, minus into minus will make it as plus. It is 1 by s minus 2 minus 3i into, so the integration of this is, it is e to the power of minus s minus 2 minus 3i of t divided by minus s minus 2 minus 3i, and the integration is from 0 to infinity. This is what you will get. Now you see that this is equal to imaginary part of, it is 1 by s minus 2 minus 3i into, see when you apply the first limit, the infinity, when you apply the first limit infinity, e to the power of minus infinity is 0. And if you apply the second limit, this minus into minus will make it as plus, e to the power of 0 is 1. So this is nothing but into 1 by s minus 2 minus 3i. So this is nothing but, so what you will get here is that it is imaginary part of, it is 1 divided by s minus 2 minus 3i whole square. So this is what we will get. So this is equal to, so this is equal to imaginary part of, I will write something here. So this is s minus 2 plus 3i, s minus 2 minus 3i into s minus 2 plus 3i whole square. So this is, I am multiplying the numerator and denominator with the conjugator. So you get this s minus 2 minus 3i is multiplied by s minus 2 plus 3i. So what that you will get here is, it is s minus 2 plus, I will write it here like this. So it is imaginary part of, it is s minus 2 plus 3i divided by s minus 2 whole square plus 9. A plus ib into a minus ib is a square plus b square. So this you get s minus 2 whole square plus 9. This is whole square. So this is equal to, you will get this as imaginary part of, you do this, square this, s minus 2 whole square plus 6i into, then I write it here like this, it is minus 9 plus I 6 into x minus 2, a plus b whole square is a square plus 2ab plus b square. So I am getting this as s minus 2 whole square minus 9 into 2 into s minus 2 into this will be I 6 of x minus 2 whole divided by, see this, whole divided by, it is s minus 2 whole square plus 9. Therefore, see what is this? Therefore, see, I will take the imaginary part. Therefore, L of t into e to the power of t sine 3t is equal to, take the imaginary part of, it is nothing but 6 into s minus 2 divided by s minus 2 plus 9, this is whole square is here. You square this and this is s minus 2 whole square plus 9 whole square, that is s minus 2 whole square plus 9 whole square. So there is the Laplace transform of L of t e to the power of t sin 3t is this one. See, this is method 1. I will give it as method 1. This is method 1. See, the method 2 I will take. This is my method 1. I will use the next method and see whether we are getting the same result. Okay. Now, see method 2. Again straight, I am applying straight away here. So method 2. See, L of this, L of t e to the power of 2t into sin 3t is equal to, it is minus f dash of s, where f of s is equal to L of e to the power of 2t into sin 3t, which is nothing but, see, this is 3 divided by s minus, see, s squared, here actually it is x squared, you will write it as, see, it is, you have to write this as 3 divided by s squared plus 9 and s to s minus 3, s goes to s minus 2. So this will be equal to 3 by s minus 2 whole square plus 9. So therefore f dash of s is equal to 3 divided by s minus 2 whole square plus 9 whole to the power of whole dash. Differentiate with respect to this. So this will be equal to, this will be 3 into, so differentiate this, you have to differentiate this. This is minus of 2 into s minus 2. The differentiation of 9 is 0. Whole divided by s minus 2 whole square plus 9 whole square. This is what you will get. Now substitute in this, therefore L of t into e to the power of 2t sin 3t is equal to minus, it is minus of the value of f dash of s, this, it is minus 6 into s minus 2 divided by s minus 2 whole square plus 9 whole square. So minus into minus will make it as plus. So 6 into s minus 2 divided by s minus 2 whole square plus 9 whole square. So you see that 6 into s minus 2 divided by s minus 2 whole square. So this and this, see, these two are the same. So this you can do like this, or you can also do like this. So this is a sample that I have taken. In coming days I will do more problems, difficult problems I will do. Now let me take one more problem in this. This is nothing but finding the inverse of the Laplace transform. Now here you see that I will write. Now I will use using partial fractions. Let us solve using partial fractions. Now 4s minus 8 divided by s square plus s let into s square plus 1 be identically equal to a by s. See, this you can write this as in, you can write this as 4s minus 8 divided by s square plus s into s square plus 1. This is 4s minus 8 divided by s into s plus 1 into s squared plus 1, which is identically equal to, you can take it as a by s plus b by s plus 1 plus cs plus d divided by s squared plus 2. So this will give, this gives it is a into s plus 1 into s squared plus 1 plus b into s squared plus 1 into s plus cs plus d into s squared plus s is identically equal to 4s minus 8. So call this as 1. Let s is equal to 0. So when you put s is equal to 0, this will become 0, this will become 0, this will become a. If you put 0, it is a is equal to minus 8. Then put s is equal to minus 1. Put s is equal to minus 1. This will become 0 and this will become 0. And so you are left with here, it is minus 1, 2, it is minus 2b is equal to, it is minus 1 means minus 12, which implies b is equal to 6. So this is what you get. Then c, if you want to get the value of c, here you want to get the value of c, cs squared. So, and here you get plus b, and here you get plus c is equal to 0. Equating the coefficient of s cubed. Equating the coefficient of s cubed on both sides, there is no s cubed here. So it is a, it is plus b plus c is equal to 0. A is minus 8 plus b is minus 12. This plus 12, it is 6 plus 6 plus c is equal to 0, which implies c is equal to 2. So we have got c is equal to 2. Now we equating the coefficient of s on both sides. So if we take the equate the coefficient of s on both sides, here you will see that here it is s squared. S squared. See, cs squared, ds squared. Here s squared will not be here. Here 1a squared, a plus c plus d is equal to 0. A is minus 8 and c is 2 plus d is equal to 0, which implies d is equal to, it is 6. So your d is equal to 6. So you get the value of d is equal to 6. So you see that what I have done here is that I am splitting this into partial fractions. I get this equation. In this equation, I put s is equal to 0, thereby I get a is equal to minus 8. If you put s is equal to minus 1, this becomes 0 and this expression becomes 0. So simplifying, you will get the value to be here 6. Then I equate the coefficient of s cubed on both sides. Using that, I am getting c is equal to 2. Equating the coefficient of s squared on both sides, I will get d is equal to 6. So I get the value of this to be this. Therefore I can write, see, this is the problem that we have to solve. It is 4s minus 8. I write it here. It is 4s, therefore 4s minus 8 divided by s squared plus s into s squared plus 1. This can be written as a. See, this is 1. See, 1 becomes. See, in the place of a, I have here minus 8 by s plus 6 by s plus 1 plus, what is your c? C is 2s plus d is 6 divided by Now I split this into partial fractions. Now I have to find this is the, I want to find the, say this is one. Therefore, I am able to split this into partial fractions. Now, L minus 1 now, 4s minus 8 divided by s squared plus s into s squared plus 1 is equal to L minus 1 now minus 8 by s plus 6 by s plus 1 plus 2s plus 6 divided by s squared plus 1. This. Now you see that the inverse Laplace transform linearity property holds good. So I can write this as, see, this is equal to L minus 1 of, it is minus of 8 by s plus L minus 1 of 6 by x plus 1 plus L minus 1 of 2s plus 6 1. Okay. This is what we get. So you see that here constants can be taken outside, linearity property and also the constants can be taken outside. You can write this as it is minus 8 into L minus 1 of 1 by s. And this is plus 6 into L minus 1 of s plus 1. S plus 1. Plus it can be written as 2 into s by s square plus 1 plus 6 into L minus 1 of 1 by s square plus 1. So this is what we have. Now this is nothing but what? So this is minus 8 into, this is L minus 1 of this is nothing but your t to the power of 0. Actually speaking, this is t to the power of 0. The Laplace transform of t, 1 is 1 by s. Laplace transform of what t to the power of 0 is 1. So you can write this as no. So I can put it as 1 or t to the power of 0. It is 1 by s plus 6 into e to the power of minus t plus 2 into, see, s by s square plus 1. This is nothing but your cos of t plus 6 into, it is s square plus 1. It is a 1 here 1 square. If you want, you can take this to be your 1 square, 1 by 1 square. So this is nothing but your sin t. So the answer is therefore L minus 1 of 4s minus 8 divided by s square plus s into s square plus 1 is equal to, it is minus 8 plus 6 into e to the power of minus t plus 2 cos t plus 6 sin t. Note, see, Laplace transform of t to the power of 1 is equal to, it is nothing but 0 to infinity of t into e to the power of minus st into dt. Use Bernoulli's method of integration, you will get e to the power e, it is t into e to the power of minus st divided by minus s 0 to infinity minus integral of 0 to infinity, in differentiation of 1 is 0, it is e to the power of minus st divided by minus s into dt. Now this is nothing but, this gives you 0 and this value is, again it is 1 by s into e to the power of minus st divided by minus s, it is 0 to infinity, that is equal to 1 by s squared. 1 by s squared. See, L of t squared will be equal to, it is 0 to t infinity, it is t squared into e to the power of minus st into dt. So use Bernoulli's method of integration, it is t squared into e to the power of minus st divided by minus s 0 to t minus 2t into integration of this is e to the power of minus st minus into minus, this is s square 0 to infinity plus a differentiation of this is 2 into this is e to the power of minus st divided by minus s cube. It is 0 to infinity. That will give you, it is, see, this is 0, this is 0 and this is minus, so you will get this to be 2 divided by s cubed. Likewise, if you proceed, you will get similarly L of t cube will be equal to your, see, it is nothing but you will get it as 6, see, 6 by s to the power of 4, 6 by x to the power of 4. Therefore, L of t to the power of n will be equal to your n divided by n factorial divided by s to the power of n. So, therefore, I write here L of t to the power of n is equal to, it is n factorial divided by t to the power s to the power of n plus 1. So, this is nothing but, you just see that this is nothing but 3 factorial divided by s to the power of 4. This is 3 factorial divided by s to the power of 4. This is 2 factorial divided by s to the power of 3. So, this is the minimum. See, I am using this idea here. So, you put t is equal to 0 here. 0 factorial is 1. So, put here this t is equal to 0, there is nothing here. So, t to the power of 0, 0 factorial is 1. And in the case of n, you put 0, it is yes. Therefore, you are getting what? Here, yes. So, this is how we do the problem. I will do more problems in the coming days. Thank you.